Yes, welcome to DC Economics. So coherently, we are going to talk about the estimate in econometrics. And so far, estimates refer to the calculated values of parameters or coefficients obtained from statistical analysis of data. So these estimates are crucial for understanding and quantifying the relationship between variables in economic and social systems. So economics involves applying statistical techniques to economic data to establish empirical relationships and basic economic theories. So the estimates actual calculated values of parameters or coefficients obtained from the statistical analysis of data. So most of the economicians or the economists involves applying the statistical techniques to economic data to establish out empirical relationships and test the economic theories. So the parameters or coefficients are actually drawn from the econometrics equations. We have a mathematical model, and we have also the stochastic model, whereby stochastic model include the error term, while the mathematical model does not include the error term within. So the following are some of the key concepts related to estimate in econometrics. The first one is parameters or coefficients. In economics, econometric model values variables are used to explain or predict an economic outcome of interest. So parameters or coefficients represent the strengths and directions of the relationship between these variables. For example, in a simple linear regression model, the estimated coefficients represent the change in dependent variable for one unit change in the independent variable. So these are the key concepts related to estimates in econometrics. And as I told you earlier, the parameters or coefficient, the first concept. So it's used to explain or predict an economic outcome of interest. So these parameters or coefficients present the strengths and direction of the relationship between the variables. So these we call the parameters. We actually present them as a K, or sometimes called the coefficients. So in a simple linear regression model, for example, in a simple linear regression model, the estimated coefficients represent a change in dependent variable for one unit change in dependent variable. Dependent variables we sometimes call the predictor variable, and an independent variable becomes sometimes called the explanatory variable. So second one is estimation techniques. Econometrics use values estimation techniques to calculate the parameter estimates. So these techniques include the ordinal least square or RLS, the maximum likelihood estimation, instrumental variable, and the other more. So actually the goal is to find the estimate that best fits the data and capture for understanding the economic relationships. So these are estimation techniques, or RLS method and the other method as well. So we actually apply these techniques to quantify and understand the values that are obtained from the coefficients beta naught, beta 1, so as we can properly estimate the linear regression model. The third concept in estimates in econometrics is hypothesis testing. So once the estimates are obtained, now econometricians often perform hypothesis tests to determine whether the estimated relationships are statistically significant. So this involves comparing the estimated parameters to their standard errors to determine if the relationships are likely to exist in the larger populations. Another key concepts as well, apart from the hypothesis testing, is the confidence interval. So this the fourth concepts involved in estimates in econometrics. The confidence interval estimates are often accompanied by confidence intervals. So the estimates are often accompanied by confidence intervals which provide a range within which the true population parameters like to fall. So these intervals give the sense of the precision of the estimates and the level of uncertainty associated with it. So actually the confidence interval is actually calculated by using its formula. The two formula, when we are given we actually place the Z test or the T test, depending on the data, the nature of the data, and particular problem that is solved. Another key concept is goodness of fit. We sometimes is actually measured as R square. This estimate involves finding a model that fits the data well. Say the goodness of fit measures the coefficients of determination, that is R square, and it assesses on how well the estimated model explains the variability in the dependent variable. Another key concept in estimates that involves in estimates information econometrics is endogeneity and bias. So the estimation in econometrics can be challenging due to the issues like endogeneity. That is what we call where variables are correlated with error terms. The endogeneity happens when where the variables are correlated with error terms, and bias. So econometricians use values method to address this issue. Econometricians use values method to address these issues and obtain the reliable estimates. Another key concept involved in estimation in estimates is causality. The causality that while now the econometrics analysis can establish correlations between variables, so establishing causality is more complex. So careful design use of appropriate control variables and consideration of economic theories are necessary to infer the causal relationship from the estimated coefficients. So we looked up the causality. Normally the assumptions under the linear regression model is actual determines or show that independent variable, that is our explanatory variable, is the one that counts the changes toward the dependent variable. The dependent variable is actually called the predictable variable. So another key concept involves also in estimation econometrics is multicollinearity. In models with multiple independent variables, that multicollinearity normally occurs where the independent variable, that is explanatory variable, are highly correlated to each other. So this can lead to unstable parameter estimates and difficulties in interpretations. So in essence now, an estimates in econometrics helps economists and researchers to quantify the relationships between economic variables and make predictions, test economic theories and inform policy decisions. However, obtaining meaningful estimates requires a careful consideration of statistical assumptions, the data quality, and the economic context in which the analysis is conducted. It will be better now we talk also about the types of estimates in econometrics. After understanding the key concept involved in estimation econometrics, it's better now we talk about the types of estimates in econometrics. You need to understand that in econometrics, there are several types of estimates that are commonly used to quantify the relationship between the variables and to draw a meaningful conclusion from the data. In actual, these types, some of the key types of estimates include the point estimates. The first types of estimates we're talking about is the point estimate. So the point estimate, these are the single values that are calculated from the data to estimate the true value of the parameter. A good example of the point estimate is the coefficient of a variable in a linear regression model. The coefficient of a variable in a linear regression model is a point estimate of the true population parameter. The coefficient of a variable in the linear regression model is one among the point estimate of the true population parameter. Suppose we have y is equal to beta naught plus beta 1x1 plus beta 2x2. So the coefficient we are talking about on the bit naught at between the independent variable and beta naught. Another type of estimates is the interval estimates, or sometimes called the confidence interval. So Instead of providing a single point estimate, now the interval estimates, or we call the confidence interval, provides a range. We provide a range within which the true parameter values like to fall within a certain level of confidence. So the confidence interval takes into account the uncertainty in the estimates and provide a sense of the precision of the estimate. Also, another type of estimates include prediction intervals. The prediction intervals. Similar to confidence interval, prediction intervals provide a range for the future value of the dependent variable based on the estimated model. So the prediction intervals normals account for both the uncertainty in the estimate and the variability of the data. So under prediction interval, it's called the prediction as it predicts a future value of the dependent variable, the future value of the dependent variable from a dependent variable. So a prediction interval normally shows the future value of dependent variable based on the estimated model. It depends now the estimated model is multiple linear regression model or simple linear regression model. Remember, under simple linear regression model, there is it shows the relationship between one independent variable and another dependent variable. But the multiple linear regression model shows one dependent variable more than other independent variables. Another is key types of estimates is marginal effects. In a model with multiple variables, the marginal effects represent the change in the dependent variable associated with one unit change in the dependent variable while holding other variable constant. So the marginal effects helps in understanding the impact of individual variables in the outcome. So, and the marginal effect, the multiple variables, the marginal effect normally represent the change of a dependent variable, or is sometimes called the explanatory variable, or is sometimes called the predictor variable, that is associated with one unit change of an independent variable. An independent variable we call the predictor variable, or sometimes they call the explanatory variable. Dependent variable we normally call the predictable variable in the linear regression model. So marginal effects help to understand the impact of individual variables. Another is elasticities. Elasticity measures a percentage change in one variable in response to 1% change in another variable. So the price elasticity of demand and income elasticity of demand are common examples. Another key type is instrumental variable estimates. In cases where the endogeneity correlations In cases where there is endogeneity, this means that the correlations between independent variables and error term is called the endogeneity. This is concerned that instrumental variable IV estimates are used. So the IV estimate use the instrumental variable, or the instrumental variable estimate use the instruments variables that are correlated with the potential endogenous variable, but not directly correlated with the error term to obtain the consistency estimates. Another key type of estimate is the maximum. Is what we call the maximum likelihood effect. The maximum likelihood estimates. This is another kind of estimate that is used when the goal is to find now the parameter values that maximize the likelihood of observing the given data under a specific statistical model. So it is commonly used in models with discrete choices and certain distributions. So if the goal is to find the parameter values that maximize the likelihood of the observing given data, we have to apply the maximum likelihood effect. It's involved in maximum likelihood effect. Another type of estimate is panel data estimates. This involves the observation on the same entities, or the entities include individuals, countries, firms, and so far. So over the multiple time periods. So the panel data methods allows for the estimation of parameters that capture both the cross-sectional and temporal variations. Also, another type of estimates apart apart from the panel data estimates, is the time series estimates. The time series data estimates involves observation taken over consecutive time intervals. Time series estimation techniques are used to analyze the patterns. The time series estimation techniques are used to analyze the patterns, trends, and relationship within the time-dependent data. So non-parametric estimates under what is known as a time series estimates is actually consider the consecutive time intervals. So time series estimates are actually applied to analyze most of the patterns, trends, and relationship within a dependent variable or within the exponential variable data. Also, we have the non-parametric estimates. This is another kind of type of estimates. And what is known as non-parametric estimates, these are used when the underlying function form of the relationship between variables is not specified. If not, it is actually applied if the function form of the linear regression model or the function form of relationship is not actually identified. So this method actually provides estimate without assuming a specific function relationship. Also, the last type is what is known as another types. The last one, that is the type of estimates, is simultaneous equation estimations. In cases where now the multiple equations are interrelated, simultaneous equations estimation is used now, is actually applied. The case is that whenever there is a multiple equations that are interrelated, this means that there's equations that are interrelated to each other, simultaneous equation estimation is actually applied. So under this approach now, it takes into account the mutual dependence of equations and estimate the parameters joined. So each type of estimate has its own advantage and limitations. Remember, we have tried to pass through all these types of estimates, but remember that each type of estimate has got its own advantages and disadvantages. And choice of the estimation methods may depend on the research question, the data at hand, or maybe and the assumptions that can reasonably be made about the underlying relationships. So econometricians carefully select the appropriate estimation techniques to ensure that the estimates now are reliable and meaningful for the analysis to be conducted. So after saying so, that's marked the end. Welcome to this economics. Don't forget to subscribe and watch on other videos. Bye bye.